have, just like a human being. So we train a model in such a way that it behaves exactly like a human being.
Yeah, yeah, exactly, Gagana.
Yeah. So have you ever wondered about the differences between AI, ML, and deep learning?
So we are going to discuss about the difference between AI, ML, and DL here too.
Okay, so let me tell you first about artificial intelligence. So, artificial intelligence is a branch of computer science and it makes machines to think without any human intervention. So, that is like no human being is involved in making decisions. The machine itself is trained in a such a way that there is no need of a human being.
And machine learning. Machine learning is a subset of AI that uses statistical learning algorithms to build smart systems. The ML systems can automatically learn and improve without explicitly being programmed. For example, if you train a model again and again and again and teach them better, teach the machine better, it improves its accuracy and gives us a perfect solution, accurate solution without any errors.
So, last but not least is deep learning. So, again, deep learning is also a subset of artificial intelligence, but here, this deep learning is mainly concentrated on the human brain. Just like, it concentrates on the how the information is getting filtered. So, this is the difference between the artificial intelligence, machine learning, and deep learning.
I think you have a basic idea about what are AI, ML, and deep learning. So, so this machine learning contains a total of 5 steps, and they are: focus on the user, define objective, collect data, train and test model, and predict and evaluate. So, for an understanding, let us consider an example. Just think that you are buying a house. Here, the user is you, and your objective is to own a house. Okay, so you will collect the data on house prices in the last few years, and then you will test it with the house you are purchasing, and then you come to a conclusion about the price of the house. Like, for example, if you want to buy a house, then you will go to a real estate owner or a real estate user. So he will give you about a basic idea of, here in this place this land costs about this much, and there that land costs that much, like that. So it predicts the houses based on the data that has been given to you, given to the model. That's the process of machine learning, and it contains of 5 steps. First, focus on the user. Next, define the objective and collect data, and train and test model, predict and evaluate.
Okay, so now we will be providing you a link in the chat box so that we will drive you through a course and put a experience like you will be certified as well. So we just want you to click the link below and just open the Kaggle account.
I have mentioned the link in the chat box. Just click on it. So first, click the link and explore the website. Before doing that, the first step is you need to sign in with your Gmail. Okay. Next, create a valid username, like the way you want your name to be printed on your certificate. So you will be getting a certificate if you are going to do this course. We want all of you to click the link and open the website and sign in. After you have signed in and created a valid username and accepted the terms, just click on the first course link that mentioning how models work. Yeah, you will get a certified certificate from Kaggle.
So this is how it looks. Just click on sign in and then sign in with Google and enter invalid email ID.
We want you all to do it parallelly so that you will also get an hands-on experience on how to do these exercises.
So please put yes in the chat box if you have already created this account and you're just ready to, you know, do the course with us.
Yeah, yes, yes. Okay, ready, ready. More, I want more in the chat box. Okay. After you completed the sign-in process, you will see a web page like this. Just you have to click on the first lesson that mentioned how models work.
So put yes if you have already come up to this page.
Good.
So are we ready to start the course?
I guess so.
So
Menu.
are you people ready? Just split your screen and put up the tabs so that you can work through parallelly.
You can watch both the screens like in a parallel way, simultaneously.
So you can just watch our presentation and parallelly you can do your coding.
Yeah. Okay.
Okay, now all you have to do is click on the begin course. So here we have an introduction. So let me drive you through this introduction first. So what exactly we will be dealing here is we'll have an overview of how exactly a machine learning models works. Here model is nothing but a machine. And we will also come through how they're used actually. So let us have an example to understand this in a better way. Suppose let us consider two people, you and your cousin. Your cousin is already speculating in a real estate, so he has millions of dollars in his pocket. So again he offered you a business part, I mean like he wanted to partner with you in this, real estate business because you are really interested in data science. So what he will do, his his work is to supply the money for you, and you will be supplying the models. Models are nothing but machines. So here you will supply the machines in such a way that those machines are capable of predicting how various houses are worth it. Like if suppose here the main example we are going through is buying a house. So real estate is nothing but selling a house, or it is all about houses, right? So what your aim is that you need to develop a model which can predict the value of the houses. So if you have noticed, like you are new to this, so then you'll ask your cousin like, how do you predict the real estate values in the past? So he'll just say that we will have a price patterns here. Like for example, let us consider a very basic example. Suppose you're going for a shopping. So we have different of brands like whatnot. We have Biba, some Raymond. So these all are brands. So how do you identify those? By seeing the sticker on the dress, right? So Biba dresses are a pattern, because those are like those dresses are related to the Biba showroom. And similarly, Raymond dresses are related, the Raymond sticker is related to the Raymond showroom. So the Biba is a different pattern, and similarly the Raymond is a different pattern. So here in the same case, like the houses, we have a different structured houses, like we may take as a villa, twoplex, or triplex, or whatnot. So here, if you wanted to purchase a villa, then you will look after the patterns of villa. Like previously in the past years, how cost does it have, or in the past 5 6 years. So the machine learning works in the same way. So we'll start with a model called decision tree. So this decision tree is used for predicting the accurate values. So let me tell you an example to clearly understand this. So here we have a simple decision tree. So here you wanted to have a house more than 2 bedrooms, or only less than 2 bedrooms. Like here it is an example. Does the house have more than 2 bedrooms or not? So you are looking for the bedrooms. So here, if it has more than 2 bedrooms, then it costs something like around $18800. If we have not more than 2 bedrooms, then it costs different price. So here the house part, like the house is divided into two categories. One is with more than 2 bedrooms, and other one is without 2 bedrooms. So here we have divided the data. So we use the data to decide. So here it is the data, and we use the data and divided it into two groups. So again, this is a step of capturing patterns. Here, if it is more than 2 bedrooms, it is one pattern. If it is less than 2 bedrooms, then it is another pattern. So the step of capturing patterns of data is called fitting or training the model. So hope you're clear. Am I going fast?
No, Lisha, not at all.
Okay. So let me tell you this. So here we are capturing patterns, and from this data, so it is called a fitting or training the model. And then the data which is used to fit the model is called training data. So now let's move on. So here we have we have come up with an sample decision tree, which is like, does the house have more than 2 bedrooms? Yes or no? And let's look into this decision tree. Here we have two decision trees. So the first one says that, just look, it has the same data. Does the house have more than 2 bedrooms? So both of the decision trees consist the same data, but look at the price here. There is a price variation. So the decision tree in the left, that is the first decision tree, probably, it makes more sense, because the in general, if we look into the prices, if the house have more bedrooms, then it tends to have the higher price compared to the fewer bedrooms. But what exactly is, here we are looking at the area, not the bedrooms. Like for suppose, if the price variation is the price variation does not come with the bedrooms, or like how many bedrooms you have. Here what we are considering is, we are considering the factors, like if it is near to a highway, then it would have a different cost. Or if the house is in a village, then it have a different cost. So it relates to the place where you're buying, and it relates to the size, and it relates to the location. So the price variation depends on these factors, not exactly on the given data. So here, see, that is what we have here. So look into this. Does house have more than 2 bedrooms? Yes. Then we'll look into the size. So here, if we have larger than 11,500 square feet, then yes, this is the price. If if the size is less than, like larger than only 8,500 square feet, then we have a different price. So here we predict the price of any house by tracing through the decision tree. So decision tree help you to split up the data that we have, and it gives you a clarity on the task that you're doing, and it shows you the accuracy. So that is the reason why we use decision tree. And the point at the bottom where we make a prediction, so these are the prediction prices, right? So these are called leaves. So have you understood all of this? I want you people to respond. Okay, so now I want you people to click on this, examine your data. So just click on the examine your data, and here you'll find another theoretical part or a tutorial part. Have you clicked it? Respond, guys.
Yes, we have picked it.
Okay, so here we have come up with some technical terms called pandas. So pandas is a library which we will be using to familiarize ourselves with the data. Like we need to get a clarity with the data, right? So we use panda library for this. So it is a very primary tool for manipulating and exploring the data. So the pandas library is denoted by PD. And here we use this command for importing the library into the, for the in the coding. So import pandas as PD. So this is what we will be using. And the most important part of the pandas library is data frame. So data frame is nothing but the data that you're putting up in a table. So that is called as a data frame. See, this has like rooms, price, distance, postcard. So this is a data frame which consists all the data related to your task. So now you're clear. Are you ready to start your coding exercises now?
Yes.
So from here, we'll be starting our coding exercises. So click on your first coding exercise. So have you arrived into this page? Were you people on this page?
Yes.
I want all of you to respond. Okay, so before we get into the coding part, just run this so that it is a setup. Just click on this and you'll have here the session is starting. So have you clicked it?
Yes.
Cool. So all of you have done it. Did your session start? Yes. See, this is how it comes.
Yes, got it.
So scroll down. Here we have step 1, loading data. Right. So here we have a new term called IOWA file path. So this is a space that is already created in the memory so that you'll put your data into this. Got it? And here home data is a data frame. That means home data is a table that consists of all the data. So all we need to do is we are gonna fill up these blanks. So just follow me now. So here what they have mentioned, fill in the line below to read the file into a variable home data. So we will now use pd dot read, because we are reading the file into the home data. So we'll put up read csv, and in the brackets, open the brackets where we are putting up. So we already have a file path like IOA file path. So we are reading this and we are assigning it into the home data. So we will put IOWA underscore file underscore path. Have you typed it? Yes or no?
Yes.
Cool. So all of you have done it? చెప్పండి చేశారా?
If
My
you wanted to do it on your own, then just see this step one dot hint, just remove the hash before the line so that you will get a hint.
see, I'll show you.
Yeah,
Remove the hash and click on this.
hint.
See,
So he said
this is
that
a
use,
function.
yeah,
Use the function pd.read underscore csv. So I think all of you have typed. So now let's run it and see whether the code is correct or not. See it, here it goes. It says it is correct.
if you still face any other problem about regarding if you didn't get the solution using the hint, you can still see that there's another line in the below code section named step one dot solution. So remove the hash, you will see the solution. That's the solution. Give it a try, guys, first. Did everyone complete the first code? It's successfully compiled.
Yes.
So how many of you have got it correct?
I got it correct.
Cool. So what about others? చెప్పండి, మేమేం టీచర్స్ కాదు, మేము కూడా మీలాగే నేర్చుకొని చేసాము. Did you check like what exactly you have typed? Did you compare the code with us? Someone got trace break error. So is it matching with our code? You have to look at the spaces also. Here the spaces also matters the most.
Don't edit the code that is previously mentioned.
Just fill the lines,
Fill
that's
the
it.
lines, yeah, the blank lines.
So can we go into the step 2 part?
Yes.
Okay, so here it says print summary statics in next line. So what exactly do we need here? We need the data table, right? So what we will do, here we have a data frame called home data, right? So It asked print, so we'll obviously use print. And what is our data frame? Home data. And what do we want? Summary statics. That is nothing but the table. So we will use describe. And open bracket, close bracket. So now run it. See, you have got the table. Are you done with this?
Yes.
Just put up yes if you're unable to talk, so that we'll come to know how many of you are doing with us.
Did it. Done.
Okay,
F2.
sure.
Okay.
See, here it says that print summary statics in the next line. So it is nothing but here it is asking for the table to be displayed. So the data frame here, see, just go up. Here we have already mentioned that Pandas data frame is called home data. I have mentioned that data frame is nothing but a table that consists of the relevant data. So here it asks for the summary. So here we will use the table name, that is home data dot. We want the table to be displayed, right? So we will use describe for it. So describe is used to, put up the details in the table. Got it now? Yeah. So now let's move on to the other one. So here it says, what is the average lot size? Just scroll down. Here we have the table, right? So here, just look what do we need the lot size? That is nothing but the area we need. So in the table here we have mean. So mean is nothing but the average. So here the mean in the lot area is like 10,516.8, which is nothing but 10,517. So put up 10,517. So now again here, as of today, how old is the newest home? Current year, the data in which it was built. Okay, so here, just look here. Here it has 2010, the year sold. So it is established in the year 2010. So now the current year is 2022, right? So 2022 minus 2010, how much is it? 12. So put up 12 and run it. And it says it is correct. So have you understood this? Others?
Yes, got it.
Okay, so for our first exercise is done. Now shall we move on to the other exercise? Shall we?
Yes, sure.
Okay, I see only Satvika is responding. What about others? Okay, so now just scroll it down and keep going. Here we have keep going, right? So here you are ready for your first machine learning model. So click on it. So this is an example for you to understand. So there is nothing much to describe. I'll directly tell you people. One thing I'll tell you here in this theory part, what you have to learn is, here we have the other library which create our models. So we will use scikit-learn library, SCIKIT learn library, and in short we'll say it as sklearn. So this library will be used to create your models. So we have like 4 steps for building and using a model. So first, what do we define? What type of model will it be? Like, is it a decision tree or is it a random forest or whatever it might be? So what type of model will it be? First, you need to be aware of that. And next, capture patterns from the provided data. So we need to segregate the patterns according to the given data. That is nothing but fitting. Next, predict. Predict in the sense, like, as I've mentioned in the earlier example, like buying a house, predicting its price, and then evaluate. So these are the 4 steps that we require for building a model and using a model. So are we ready to do the other exercise?
Yes.
So only these things you need to remember for doing this exercise. Remaining everything I'll tell you in the code itself. So just click on it. So have you arrived into this? Come on, tell me. Are you ready, people?
Yes.
Cool. I see a lot of responses now. Okay, so as usual, first you need to set up your compiler. So just click on it. You need to start the session with this. If you do not run this, you will get errors. Anything won't be executed. So just look into it. Okay, so it says session started. So now let's move on. So here it says print. First one here, it says print the list of the columns in the data set to find the name of the prediction target. So here it says print the list of the columns in the data set to find the name of the prediction target. So what we need to do is we need to display all the columns in the data frame. That is nothing but the table. So what is a table name? I have mentioned it, home data. So type home data dot, what do we have to display? It asks for columns. So click columns. So now run it. So look, here we have got all the columns that we have in the data set, right? So have you people got this?
Yes. We got it.
Okay, so and here in the top, under the step 1, they have mentioned that select the target variable which corresponds to the sales price and save this to a new variable called y. So what do we have to do is we need to assign a column from the data set. That is, what is it? You people tell me. What do we have to assign to a new variable?
Values.
No, I've mentioned. Just now I've read it. Select the target variable which corresponds to the sales price. So we need to assign the sales price from the data set to a new variable that is called y. Got it? So what do we have to do now? Here y is equal to, so what do we have to assign? We need to assign a column from the table. So what is our table name? Home data. So we have put up the table name dot which column are we assigning, which is similar, which is sales price, right? So here sale price. Just look at the capitals and small letters also. So now run it and it says correct. So here we have allocated the sales price into a new variable. Got it? Are you people done with this?
Yes.
Okay. So now scroll down and here we have a step 2.
Lisa, someone says they didn't get that.
Okay. Okay, so let me tell you this. Here, just look here. It says select the target variable which corresponds to the sales price. So here the target variable is sales price. And this sales price have to be saved into a new variable called y. So this sales price is in a table called home data. The table name is home data. So here we have put up the table name home data dot sales price because the sales price is being assigned to the new variable y. So have you understood now, Hemant? Okay.
Lisha, I'm unable to start my session.
Like, is it? Did you run it? Did you run it and see, Hina? Yeah, just refresh the page and.
Yeah, first, the first one is complete.
Okay, just once
Yeah, I
refresh
refreshed
or
it, but it's not working.
it might be maybe problem with the Wi-Fi or even because is it taking too long to start or
Yeah,
is it giving any error?
no, it's taking too long to start.
Can you share us your screen and show us like ఒకసారి చూపించు, then we'll say what.
Yeah.
It is still buffering, right?
Due to some network problem, I am unable to share my screen.
Actually, I think it is a network problem because it is taking too long to run. So
Yeah, okay.
yeah. So now let's continue with
After
the step.
after I get a proper network connection, it is able to run the code, right?
Yeah, you
Can I
can
run
do
the
it.
code?
Yes, yes.
Yeah, okay. Thank you.
Yeah. Okay, so now let's move on. So here in the step 2, look, here we have lot area, year built. So first floor SF, second floor SF, full bath, bedroom, ABV, GR or whatever. We have some names here, right? So these are the list of features. And these features we are using in order to create a data frame. So here we have a blanks again. Here they have asked for the feature names. So what are the feature names they have mentioned in the above? We have like 7 features, right? So just open the square brackets, and since these are strings, you need to type them in the single quotes. So first one is lot area. Just look at the capital letters and small letters. And it says year built. And
Lisha,
then,
the screen is not sharing.
sorry, one minute.
Lisha, please share your screen.
Yeah, just a minute. So is it now visible?
Yeah, it's visible.
Yeah, so these are the 7 features that they have mentioned in order to create a data frame. So in the down, they have asked for the create the list of features below. So these are the 7 features. So here, in order to create, we have opened the square brackets, and since these are strings, we need to put them in the single quotes. Yes, like similar to arrays. So are you done typing these names? So are you people done?
Yes.
Okay. So here it says select data corresponding to the features in the features names. So here, what is the data frame name? It says home data. And it asks select data corresponding to features in features names. So here it asked for the features in feature names. So in the data frame, right? So ఓకే, నేను ఇది తెలుగులో చెప్తాను, క్లియర్గా వినండి. ఇక్కడ మనకి ఏం అడుగుతుంది? ఇట్ ఆస్క్ ఫర్ ద ఫీచర్స్. ఆ ఫీచర్స్ ఎందులో ఉన్నాయి? డేటా ఫ్రేమ్లో ఉన్నాయి. సో ఇక్కడ ఫస్ట్ మనం డేటా ఫ్రేమ్ నేమ్ ఎంటర్ చేస్తాం, విచ్ ఇస్ నథింగ్ బట్ హోమ్ డేటా. అండ్ ఇట్ ఆస్క్ ఫర్ ఫీచర్స్ నేమ్స్ కాబట్టి ఓపెన్ స్క్వేర్ బ్రాకెట్స్ అండ్ టైప్ feature names and run it. Got it?
Yeah, got it.
So are you done with this? Meekemana doubt unte I'm pasting this in the chat box. Just look into this code. I've pasted the complete code in this. If you're finding any error, just replace this code with yours. So are you done?
Yes, we are done.
Okay. So now here it asks, just look. Here it asks for the print description or statics from X. Print description ante, as I have told you, డిస్క్రైబ్ చేయడం. సో ఇక్కడ దేన్ని డిస్క్రైబ్ చేయమంటున్నారు, ఎక్స్ నుంచి దే వాంటెడ్ ద డేటా. సో ఇప్పుడు క్యాపిటల్ ఎక్స్ డాట్ డిస్క్రైబ్ ఓపెన్ బ్రాకెట్ క్లోజ్ బ్రాకెట్. అర్థమైందా? అండ్ ఇక్కడ యూ నీడ్ టు రిమూవ్ హ్యాష్. అండ్ ఇక్కడ కూడా యూ నీడ్ టు రిమూవ్ హ్యాష్. అండ్ ఇక్కడ ప్రింట్ ద టాప్ ఫ్యూ లైన్స్ అంటున్నారు కదా. సో ఇక్కడ మనకి ఏంటంటే టాప్ ఫ్యూ లైన్స్ని మాత్రమే ప్రింట్ చేయడానికి హియర్ వి యూస్ హెడ్ అనమాట. హెడ్ అనేది యూస్ చేసి, హెడ్ అనేది ఎందుకు యూజ్ చేస్తామంటే ఓన్లీ పైన మనకి ఫ్యూ లైన్స్ డిస్ప్లే అవ్వడానికి విల్ యూజ్ హెడ్. సో ఇక్కడ మనం దేని నుంచి డేటాని డిస్ప్లే చేయాలి, ఎక్స్ నుంచి. సో ఇక్కడ ఎక్స్ డాట్ హెడ్ ఓపెన్ బ్రాకెట్ క్లోజ్ బ్రాకెట్. సో ఇది రన్ చేసి చూడండి.
Yeah, done, Isha.
Done?
Yeah.
Okay. So moving on. Step 3. Are you people ready?
Yes.
సో ఇక్కడ మనం థియరీ చూస్తే ఇక్కడ చూడండి, దే హావ్ మెన్షన్ డెసిషన్ ట్రీ. సో ఇక్కడ డెసిషన్ ట్రీ రెగ్రెసర్ అనేది ఒక మోడల్ అన్నమాట. సో అందుకని ఇక్కడ what they have asked, set a numeric value for random state when specifying the model. అంటే ఇక్కడ మోడల్ స్పెసిఫై చేసేటప్పుడు వీ నీడ్ టు అసైన్ అ వాల్యూ ఫర్ ద ర్యాండమ్ స్టేట్. అంటే ఇక్కడ ఆల్రెడీ ఇచ్చేసారు. సో దిస్ వి విల్ కాపీ పేస్ట్ అండ్ పుట్ ఇట్ హియర్. అర్థమైందా? ఇక్కడ డెసిషన్ ట్రీ రెగ్రెసర్ అనేది ఒక మోడల్. సో ఆ మోడల్కి మనం ర్యాండమ్ స్టేట్కి ఒక వాల్యూ అనేది అసైన్ చేస్తాము. దాన్ని మనం ఇనిషియలైజ్ చేసేటప్పుడు వీఆర్ అసైనింగ్ ఇట్ యాజ్ 1. అండ్ నెక్స్ట్ ఇక్కడ ఫిట్ ద మోడల్ అన్నారు కాబట్టి IOWA_model డాట్ ఫిట్. ఏమేం ఫిట్ చేయాలి? దెన్ ఫిట్ ఇక్కడ చూడండి స్టెప్ 3 పైన, దెన్ ఫిట్ ద మోడల్ using the data in X and Y that you saved above. మనం ఇందాక చేసాం కదా ఎక్స్కి వైకి. సో వాటి డేటా మనం ఫిట్ చేయాలన్నమాట ఇక్కడ. సో ఎక్స్ ఇస్ క్యాపిటల్ అండ్ వై ఇస్ స్మాల్. అండ్ now just run it and see. Okay, so here we have an error. ఓ ఐఎమ్ సో సారీ. ఇక్కడ పైన ఇక్కడ కూడా ఉన్నాయి కదా మీకు. ఇక్కడ ఐ సెడ్ లైక్ ఇంకొక లైబ్రరీ ఇంట్రడ్యూస్ చేస్తామని చెప్పాను కదా. సో వాట్ డిడ్ ఐ మెన్షన్? sklearn లైబ్రరీ, రైట్? సో హియర్ యూ విల్ యూజ్ sklearn లైబ్రరీ బికాస్ ఇంపోర్ట్ చేయడానికి యూ నీడ్ సమ్ లైబ్రరీ, రైట్? వితౌట్ అ లైబ్రరీ యూ కాంట్ ఇంపోర్ట్ యువర్ మోడల్. సో ఇక్కడ ఫ్రమ్ sklearn లైబ్రరీ we are importing our model called decision tree regressor. So now just run it and see. So it says correct. So again, I'm pasting this in the chat box if you have any doubts. So are you people done with this?
Yes.
So did your code execute?
Yes.
Cool. So now let's get into the step 4. So here it says making predictions. So here we have come to a step called predicting the data that we have. So here, what did it ask? To predict the model values. So here, predict what is our model? IOWA. Since we have assigned the our actual model is decision tree regressor, and we have assigned it to the IOWA model. So that is why we are putting up here IOWA underscore model. అంటే మళ్ళీ డోంట్ గెట్ కన్ఫ్యూజ్ దట్ ఇందాక ఐ టోల్డ్ దట్ డెసిషన్ ట్రీ రెగ్రెసర్ ఈజ్ అ మోడల్ అని, కానీ వీ హ్యావ్ ఆల్రెడీ అసైన్డ్ ఇట్ because this model's path is already existing in the memory. I think this is done, and check it. See, in the below you have got the values predictions. So did you people get it?
Yes.
Remaining?
Yes, got it.
Okay, what about others? Come on, put something in the chat box. So are you following me? Okay, so I think we are done with this, right? So we are done with the second exercise as well. Oh, wait. Here we need to add something else. You can write code in this cell. So what? So here it says use the head method to compare the top few predictions to the actual home values in Y. So it asked for the head method, like for the predicting the values. So what do we have to do? It home values from Y, right? Y dot head, because we need only top few lines. So then run it. We got only few lines. So are you people done with this as well?
Yes.
Okay. So this is optional, I would say. So here we have add a cell code, right? Click on this. You'll have an extra cell for typing a code, and just click y dot shape. This is optional, or you have, I mean, like, you can do it. So are you done with this as well?
Yes, do it, Nisha.
Okay, so now let's move on to the home validation part. So here we'll be dealing with the model validation. That is nothing but the absolute mean absolute error. That is the main thing that we will be dealing here. So just scroll down, and let me tell you this. Here in this, we will be using another function called train test split. So this train test split function is used because it breaks the data into two pieces. So in order to divide the data that we have, we will be using the scikit-learn library, that is sklearn library. And in that, we will also use a function called train test split. And also we will be calculating the mean absolute error for our model. So are you clear? Yes or no? Why chat box is empty? Click something. Yes.
Yes.
Only Satvika is responding. What about others? Just please respond. Okay. So now again set up the installation part. So start the session. So shall we start at step 1? Okay, now let's start. Here it says import the train test split function and uncomment. Here we used hashtags for the comment session, right? If you have to type the comment, we use the hashtag. And so remove the hashtag. And now here from what library? We need to put up the library. So what is our library? sklearn. So sklearn dot model underscore selection. What do we have to import? Train
Test train split.
underscore test split. So now here again remove the hashtag. So here it says train x, value of x, train y, and the value of y, right? So here remove this underscores and what is the function that we are using? Train test split, right? We are using train test split function. And what are the values that we need? X, comma y. And also here they have mentioned that give it the argument random forest is equal to 1 so the check functions know what to expect when you're verifying your code. So your put up random state is equal to 1. Okay, see here remove the space or else you'll get an error. And again we have got an error. Just a minute. So are you done with this? Are you getting any errors? See if you're getting any errors, just copy paste this.
No, no errors.
Okay, I'm just putting up here again. Okay, so now let's move on to the step 2. So here it says create a decision tree regression model and fit it to the relevant data. Set random state equal to 1 again when creating the model. So again, so specify the model. Here what is our model name? Decision tree regressor. Right. And here it says assign the value random state equal to 1. So we are done with it, right? So fit IOA model with the training data. So IOWA model, we need to fit the data. So we'll use fit. And what do we have to fit? Training data. What is the training data that we have? X and Y. So train underscore capital X, comma train underscore Y. Just give a gap here and click enter. So we have imported the model and then we have trained the data into the model. Are you clear with this? Are you clear?
Yes, yes, got it.
Okay.
Yes.
So now here it says predict the values, right? So here what is our model? IOA underscore model dot predict what? Value of X. Let's take X and click enter. Sorry, run it. So and it says correct. So here we are predicting the values.
Got it.
Okay, so now let's move on to the step 4. So here we are here for the to calculate the mean absolute error. So mean absolute error. So what here we have already assigned, like we have already predicted the value of X, right? So value of Y, comma, we will put up value of predictions. So now let's run it. So now we have calculated the mean absolute error in the validation data. So are you clear till now the model validation?
Yes,
So here just remove the hashtag and run again. And here it gives the value. So from here on, Bhargav will continue.
Sure. Okay, so I'll be sharing the screen. Is my screen visible?
yes,
Okay. So till now we have covered the topics like learning how to predict a model validation like that. So here in this exercise, we will be covering about two topics named underfitting and overfitting. So see, in the beginning of the course, you have seen a simple decision tree with a basic of on around three. I mean like a node and a two leaves. So if you want like if you want to add up more features, you will get a I mean like అంటే మీకు ఇష్టమైన హౌస్ ఇప్పుడు ఈ హౌస్ లో ఇది ఉండాలి అది ఉండకూడదు అని అనుకుంటారు కదా అలాగే ఇప్పుడు ఫర్ ఎగ్జాంపుల్ ఈ డెసిషన్ ట్రీ కన్సిడర్ చేసుకుంటే లాట్ సైజ్ లార్జర్ దెన్ 8500 స్క్వేర్ ఫీట్. If you are a family of two members or a three members, this I think the square feet of area would be sufficient, so you will choose for this. Or else if your family is around about a group of six or a seven, then you need a larger size of square feet. So if you add more features, then it will increase the splits. So here you can see that if it's uncommon for a tree to have 10 splits, I mean like 10 features in the decision tree, then you will get for each split you will get a data of divided into data of into two groups. Like that, if you add the groups like that, at final you will get a sum. For example, if you add a total of 10 splits, then you will get a total of 1124 leaves. I mean like different parameters and different attributes into it. So underfitting. So if you add more features, then the leaves gets divided into single parts. We don't want that. Or else it's underfitting. Underfitting means like if you allocate more houses into a single leaf, then it will be difficult to predict a value. So we need to choose an ideal point between the underfitting and overfitting, and also an ideal point between the validation and training. You don't want to choose more features that is similar to like single house, predicting the house price from a single house, or else predicting the house from a multiple houses at the same time. We need to consider the house price from a small set of houses, so that you will get a ideal price to the house that you want to choose. So here you can see from sklearn at metrics, is she already mentioned, Lisha has already mentioned this sklearn library. They have imported the mean absolute error and also imported the model that we have created earlier, the decision tree regression like that. So, and we have created a definition, like a function and a model named decision tree regressor with a max leaf nodes and random state with a value of 0. It doesn't matter which value assigned to the random state, it's negligible. Basically, it's given as 0 or a 1. So we are fitting the data into the model and predicting the value from the value x, and also we are finding the mean absolute error. So here till now we have written the code, first importing the pandas library and also the path, reading the CSV file, and also like predicting the data, and only if some features we need to gather from the data frame, like features and also some particular column, and also predicting training, and also the train test split data function like that. So we are we are comparing mean absolute error from a set of values. Like see, in this case you can see we are considering a set of values only 5, 50, 500, and 5000. So in the max leaf nodes, like in the decision tree, we consider the leaf which has values of 5, 50, 500, and 5000. So we consider the mean absolute error of these leaves only. Okay. So they initiated a for loop and also created a mean absolute error for the max leaf nodes from the values of train x, train y, and value y. And they have printed the values max leaf nodes that we are choosing, and also the mean absolute error value of the leaf node that we have selected 5, 50, 500, and 5000. See, here we can see overfitting, capturing spurious patterns that won't recur in the future, leading to less accurate predictions. Like if you want to consider with a single leaf, then with a bunch of leaf. If you consider with a bunch of leaves, you can get a accurate prediction. Underfitting, failing to capture relevant patterns, again leading to less accurate predictions. So if you consider a large bunch of leaves, then you can't predict which one is better. So we need to choose a point between here in the graph. I told that we need to pinpoint of exact value between the underfitting and overfitting, and also between the validation and training, so that we get an accurate value. So let's get into the exercise. Click the link there. You will be redirected to another exercise. Did you get it, guys? Hello.
Yeah, we got it.
Yeah, go on.
Okay. So till now we have written this all this code, like importing the modules and libraries, pandas and metrics, mean absolute error and train test split and decision tree regressor, and also we have imported the file path and also read that file path using the pandas library and also the sales price. Just run the code. Your session gets started. Okay, session has started. And validation MEAE, mean absolute error with 29,653. So without the underfitting and without finding a value between the underfitting and overfitting, the validation, I mean, mean absolute error is 29,653. We need to find an ideal value, I mean, accurate value of mean absolute error with a less error value. So we are going to modify this, and they have written a get MEAE, I mean, like get mean absolute error function already. Actually, we have discussed this one. So just let's pass this. Just execute the code as executed. So they said that candidate max leaf nodes is 5, 25, 50, 100, and 250, and 500. So they have given the array. We want to check the leaf nodes in around these from these values only. So we need to write a loop. So consider a variable scores, and in the scores we are going to write the loop in the curly brace. First we need to consider the max leaf nodes that we have already written in the MEAE function. Here you can see this one. In the getMe, we wrote the max leaf nodes function. We are using this max leaf nodes function for this loop to get the values. From the max leaf nodes, we are using the getMe function, get mean absolute error function, and mean absolute error from where from which values max leaf nodes, and also from the train x, training value of x, and also the training value of y. Yeah, these are the training values, and then we need also need to consider the value of x and value of y too. So we now consider the training value of x and training value of. Now let's consider the value of x, actual value of x, and actual value of y. So we wrote the variables that from which the data has to be taken, and also now we need to write the for loop for from where from the max leaf nodes. The max leaf nodes. This loop has to check in the array. In which array? They have given the array named candidate max leaf nodes, right? We need to check what only for these values only. So for max leaf nodes, in where in the candidate max leaf nodes, we need to check in this and loop. So finally, we need to print the best value. So to print the best value, we need to choose the minimum value, right? I mean ideal value. From we have written this all the for loop in which variable scores. So from the scores, assign it to a key, and from the scores we need to get the value. So scores dot get. So here so okay. So we need to, if you want, you can print it or else just run the code. I'm printing the value. So best underscore tree underscore size. We are going to print the best tree size value from the for loop. I mean, like in the value. Here you can see that for each and every leaf node that we have encountered the for loop, there is a main absolute error. So we need to consider the least value. I mean, with the leaf node with the least value, least error rate. So just compile the code. It says errors. Which one? Where did I get to it from? I need space, I guess. Take the wrong space. Let's try to run it again in the same error. Hmm, check it. No, same here. Yeah, okay. I think the space has been raised an issue. So I'll copy this and paste. Did you get it, guys? I mean, did you understand the code that I have written?
Yes.
Yes.
You can, if you didn't get the ideal answer, and you can use the hint here. It says you will call getMay in the loop. Yes, I did call the getMay function from the max leaf nodes, and you will need to map the names of your data structures in data structure to the names in getMay. Yeah, that's what I did. So I did max leaf node from which values I took max leaf nodes, train x, val x, value x, and train y value x. So, yeah, okay, value x. Okay. From these values, I took the from these variables, I took the values and kept in the for loop for max leaf nodes from for the which values candidate max leaf nodes. So they said that for loop has declared that the best value is 100. Among these nodes, 100 has the least mean absolute error value. So fit model using all the data. So they said fill in the argument to make optimal size and uncomment. So first let's uncomment. Final model, decision tree regressor. Decision tree regressor, we need to pass the value, that optimal size. We have stored it in the best tree size, right? So from where max leaf nodes function, we have written for the for loop. We have written for the for loop named max leaf nodes function, right? So for the from the max leaf nodes, I'm taking the best tree size. So I'm assigning the best tree size to max leaf nodes. If you want, you can give the random state or else no issues. Random state 0. Next we need to fit the values. Which values? The original values that we have to calculate, not the train x or the value x. We need to fill the value of x and the value of y. Like this is the final value, final fitting, final training, like training of the model. So we did this correct. So we found the optimal value, and also we have fit the model using all the data that we have calculated so far. Okay, did you get it, guys?
Yes.
Okay, so I need responses in the chat box. No one else is responding.
Come on, guys, respond in the chat box.
Let's see what's the hint is. So he said that fit with the ideal value of max leaf nodes in the fit step, use all of the data in the data set. So we have gathered all the data set x and y, and we have fitted the maximum value, I mean the optimal value into the max leaf nodes function. That's what he gave us the hint. We have successfully compiled it. Okay, next we are going to the next exercise, that is random forests. This is another algorithm. You have already encountered an algorithm in the machine learning, that is simple decision tree, and this is another algorithm for the random for known as random forest. So this is the more sophisticated machine learning algorithm. So if you include a lot of features, then you will get a bigger tree. I mean, like a bigger tree with lots of leaves, and it will make the model to overfit only. So because each prediction is coming from the past data that we have entered, and few horses will be remained in the leaf. So we will consider this random forest. We will be training a model using this algorithm named random forest. So till now we have wrote this code already. You all know that code. Okay. Till now we have used this one from the sklearn decision tree regressor. Now we are going to use this one random forest regressor. In the previous you have used simple decision tree algorithm. So use this function named decision tree regressor. Now we are using the random forest algorithm. We are using the random forest regressor function. So random forest regressor function will helps you find an optimal value better than the single decision tree algorithm value that was found. So let us dive into the exercise. Okay. This is all the setup that we have written so far till now. Okay, here they say that the code you have previously used it to load data. Okay, just start the session. Okay, starting. Random forest also follows the same procedures that was followed by the simple decision tree algorithm, like defining the model, fitting the data, and calculating the mean absolute error. So the setup has been started. So here you can see that validation of MAE when not specifying max leaf nodes. I mean, that was done by Lisha. It said that 29,653. When we have used the underfitting, the finding the exact point between the underfitting and overfitting value, we found the ideal value as 27,283. That means error got reduced, error value got reduced. That means we are training the model to predict a better value. So the setup is complete. Just see using the random forest. So first we are defining the model. As we all know, for defining the model, we use random. As we are using the random forest algorithm, we said that we need to use the random forest regression model name. So forest, random forest regressor, and they said that set the random state to 1. Random state equals to 1. Okay, we have set the random state and defined the model. Now we need to fit the model. We have assigned the model to a variable named rf underscore model. You can see here. So I'm calling the model, and we are going to fit the data. First, we need to fit only the training data, and next the value of data, and next the final data, that is x and then y. Okay, so first we need to fit the data of training of value of data set of x and the value of y. Okay, and they said that calculate the mean absolute error of your random forest model on the validation data. So we already know that mean absolute error, right? So we can call the function mean underscore absolute error. In the mean absolute error, we need to pass on two values. One is value of y and also the predicted value from the data set of value x. Okay, so first value of y and also we need to predict the value of x from the model. So we need considering the random forest model predict from where we have mentioned that from the value of x, value of x. So I think that's the correct. I guess so. Yeah. Here validation MEE for random forest model. As we have used the random forest algorithm, it found a precise value. Then before we have found that using the simple decision algorithm, 27,283. That's the larger value than compared to the value that is found by the random forest algorithm. Let's see what the hint he gave. What is the hint? Review the code above the decision tree regressor. Use the random forest regressor instead. He said that in the place of decision tree regressor, use the value of random forest regressor. That's what we did. We did the naming the model as random forest regressor with the random state one assigned to the variable, and the variable we have fit the data and found the mean absolute error and print the mean absolute error. Did you get it, guys? I'll copy this code. Paste it here. Did you get it, guys? Similarly, there are different types of algorithms which helps you predict a accurate value. Till now, we have learned two algorithms: simple decision algorithm, which is done we have just teach by you to you by Lisha, and I have teach you the random forest algorithm. Here it says that random forest using a more sophisticated machine learning algorithm, which gives you a sophisticated value. I mean accurate value than before. Okay, next. Shall we go to the next? Shall we proceed? Are you ready?
Yes.
Okay, let's start the next tutorial. So
I think this
here
is the
it
last one,
says,
right?
yeah, it says the course step 7 out of 7. Enter the world of machine learning competition to keep improving and see your progress. So here we need till now we have learned so far about creating a model, how to read a file, and also how to predict a value, how to create a features and assigning the values to a feature, and also I mean like model validation, finding the mean absolute error value. So if you could link and create a submission, you'll proceed to another exercise. In this exercise, the data that you have learned so far will be used in this exercise. I mean like putting to the hands-on practice till now you have learned so far. This exercise will test your, I mean learn how much you have learned. Let's start the session. Most of the code has been given by them only. We just need to overview the code and check for ourselves if we read the code or not. So the session has been started and okay, the same importing the pandas and also the sklearn. They have used the random forest algorithm, and also used the mean absolute error imported, and also the train test split. First, we need to load the data, right? So from the using the panda libraries, we read the file and they allocated the value to y from a particular column, and also assigned the features assigned to x and x. Okay. So using the random forest model, we find the value till now execution. So validation MEE for random forest model 21,857. Using the random forest algorithm, we found the mean absolute error value as 21,857. Okay, we need to find a better value than that. Okay, so first the code cell about trains a random forest model on train X and train Y. Okay, this model has been predicting the value from the value of train X and train Y. They have fit the value of train X and train Y. So we need to find the value using the X and Y values. So first, to improve accuracy, create a new random forest model which you will train on all training data that we have gathered so far using the single decision tree and also the random forest data. We will consider both the data, and first we need to create a model named random forest regressor. No need to consider the random state, just leave it blank. Next, they said that fit the RF model on full data, on all data from the training data. On all data from the training data means the data set of X and the data set of Y. Till now, we have used the data sets of train X, train Y, and also the data sets of value X and value Y. We haven't used the value of X and value of Y. So we need to fit the data into this new model that we have created using this code that we are going to call the model underscore data. We have called the model. We need to fit the data. Which data? The value of, the total data set of X and total data set of Y. Fit the X and the value of Y. Okay. So we have created the model using the random forest regressor with a new name named as RF model on full data. And we have fit the data of X and Y that we have gained so far. Gathered so far. Did I got the spelling wrong? Okay, it's a case sensitive, I guess. Forest spelling. Random forest says that random forest regressor is not dependent because I kept the f as small. So created the new model named random forest regressor using named as RF model on full data. So next path to the file you will use for predictions. Okay, read test data file using pandas. So how to read the file using pandas? Tell me in the chat box. I will use it here. How to use the pandas for reading a file. I want the answer from you guys. Yeah. Anyone else? Typing. Okay, I'll write it. ed dot read CSV. From where the file path has been assigned to the variable name test data path. Yes, test data path. Okay. Okay, we read the file, and now we need to create test X, which comes from test data but includes only the column used for prediction. The list of columns is stored in a variable called features. So they said that already the list of columns has been stored in the features here in the previous code. Yes, here features. They have already created the features variable and assigned to this. We are using these features in this code. So from where are we going to use? From the test data here, including those features, because test data includes the file that we have read from the file path that they mentioned. So test data as the features is a array, we need to mention it in the square brackets. What's the array name they mentioned? Variable called, said that it was features, right? Copy and paste. Okay, we have assigned the column that we want a specific features data and make predictions. We know how to predict the data. What the model that we have, what is the name that we have given a model? What is it? This one. Yeah. RF underscore model underscore on underscore underscore data. For predicting the value, we use the function name predict. From what? From the value of, they said that create a test x. So we need to predict the data from the test x data. So test underscore x. Compile this. Okay, it's completed.
Copy that and send it in the chat box.
Yeah. I'm just checking whether it's worked or not.
Spelling wrong.
Threads. Okay. Yeah, I think this check function won't work like that. It doesn't show an error, then it's okay. I pasted in the chat box so that we can further reference it. They said that before submitting, run a check to make sure your test pens have the right format. Okay, here it is. Step 1 dot check. So till now I've written the code. Yes, it says if the code is correct. Let's see the solution. Yeah. Okay, this in the last call cell. This is output pd.data frame. Okay, here you can see till now we have predicted the value, right? But did not print the value that how much did it predict. So let's see how much did it predict. Print the data, right? Print. So this is the data, the final data, right? Okay. The final data that is predicted. So you have completed the course, guys. Congratulations. If you want to proceed further, you can
Let's know how
consider.
many of you people have got the certificates now.
Yeah, small reminder. If you want to continue the code, you can continue your progress using this, considering these features that they have mentioned right here, and you can submit it in the competition page. I mean, like you can get the prizes like that. So if you completed the code that's last here, just click on the go to course page. Yeah, 100% completed. They said congratulations and congratulations to those who have completed the course. Just click on view certificate. Your certificate will be loaded. Yes, I have given the name as GDSC Kaggle so that it represents GDSC Kaggle. In the beginning, we told to give the name that you want to be printed on your certificate, right? The name that you give in the prior step, that name will be printed here in the place of GDSC Kaggle. You can just click in the download certificate or share to Twitter or share to LinkedIn. And also this Kaggle is a multiple this is a platform for multiple courses that you can learn, like intro to programming, Python, Pandas, machine learning, feature engineering. Like that you can find a lot of courses that are useful.
So, how
You
many
can
have
use
got
it.
the certificates already? Just put me in the chat box. I wanted to know.
Or else a hand raising emoji that you want to show. Mm, Who who did the who does
No
who
one.
did it? I'll stop screen sharing.
Yeah. So, I hope you are clear with the session, guys. If you're clear, put clear in the chat box, and we'll end this session.
If you want to contact us anytime, you can contact us in the GDSC page, our official page, GDSC LBCE page. Let me put you the link. can
So,
contact
shall
us.
we end this meeting, guys? So that's it for today, and we have a day two event on Thursday, and see you guys there. So I'm ending the link.
You can look for new events in our community webpage. Thank you. There are social media handles. You can contact us. Thank you, guys. Thanks for attending. See you in the next event, guys. Bye. Thank you.
Bye. Thank you.